മോഡ്യൂൾ 5-ലെ ലിമിറ്റ് സ്റ്റേറ്റ് മെത്തേഡിലെ പ്രോബ്ലംസ് ആണ് നോക്കിക്കൊണ്ടിരുന്നത്. അപ്പം problem number 1, a simply supported rectangular beam of 12 meters span has an effective depth of 800 mm. The area of tension reinforcement required to support the loads is designed as 1.6%. Check the deflection control of the beam by empirical method. Condition is given as Fe415 grade HYSD bars are used. Second condition, Fe500 grade bars are used. So first you want to write the given data. In this question we want to calculate the deflection control. So we already learned what are the conditions of deflection. Okay. So by empirical method we are going to solve the problem of find the deflection. Okay. So first you want to write the given data. Given data includes the span or length of the beam as 12 meter. Then the effective depth as 800 mm and the percentage of tensile reinforcement. Because the beam consisting of both compression and tension reinforcement. So here the percentage of tensile reinforcement is given as 1.6%. So here compression percentage is not given. So just assume it only it contains tensile reinforcement. Then Fy is 415 Newton per mm square. Then first we want to calculate the length by effective depth actual ratio. So just substitute the given value as L as 12 meter, that is 12, and D converted it into meter, that is 0.8 meter. So just provide the values of L and D and find the ratios, that is L divided by D actual gives 50. Then we want to calculate L divided by D max. Okay, L divided by D max, that is this L divided by actual should be within the L divided by D max. So we already know the conditions. So L divided by D max, how to calculate? L divided by D basic into KF into KC into KT. So L divided by D basic we already calculated. Okay, KF, KC, KT are the modification factors that we calculated from 3 graphs which is provided in IS 456. Okay, then what is KT? KT is, first you want to take the page number 38. Okay, you want to take page number 38. KT means modification factor of tensile reinforcement. So this is page number 38. So for calculate, this is the values of KT. Okay, this y axis gives the value of KT, that is modification factor. So first you want to calculate the percentage of tensile reinforcement, that is already given in the question as 1.6. Then you want to extend this value to this curve. So what is the value of Fs? That is there are number of Fs given in the this chart. So we want to calculate what is the curve value we want to know. So how to calculate Fs? Here Fs formula is given as Fs equal to 0.58 Fy into area of cross section of steel reinforcement divided by area of cross section of steel provided. So we already learned that assume this ratio as 1, that is area divided by area is 1, that is value is same. So we assume this as 1. Then 0.58 into 415. 415 is the Fy value. We get the curve value as Fs equal to 240. So 1.6 into Fs extend up to 240, then extend towards the y-axis. Okay, that gives the modification factor. So we give we get the KT value 0.9. Okay, we get the KT value, that is 0.6 extend towards the Fs value and extend towards the y-axis, that gives 0.9. Okay, 1.6 extend towards 240, then extend towards the this points give 0.9. Okay, then we want to calculate the next factors, that is Kc and Kf. Kc is the compression reinforcement modification factor, and Kf is the flanged beam modification factor. If compression reinforcement values is not given, that is here what compression reinforcement is not provided, then assume or take the value of Kc as 1. If in question only the Kf means the flanged modification factor, this beam is only rectangular beam. This is not a flanged section. Flanged section means it is not a rectangular beam. So this is a rectangular beam question. So assume the Kf equal to 1. If it is a flanged section, we want to calculate the value of Kf. Okay. Then just as we want to calculate L divided by D basic. For simply supported beam, this value is 20. We already discussed in the previous section. Okay. Then for simply supported, the L divided by D basic value equal to 20. Then provide all the values and calculate the L divided by D max. Then what compare with these two? So here the L divided by D actual or L divided by D max should be greater than L divided by D actual. Then second condition, provide the value of Fs as what? Fs as 5, Fy as 500, and repeat this procedure and check the condition for deflection. Okay, then go to the next section. Next problem consisting of a doubly reinforced beam. So doubly reinforced beam is it also consisting of both what consisting of tensile reinforcement and compression reinforcement. Then please write the given data. Okay, write the given data and calculate AST, ASC, FA, because here PT value is not given directly. So we want to calculate PT and PC value by using AST and ASC. So after finding L divided by D actual, we want to calculate L divided by D max, but we want PT value. So how to calculate 100 AST divided by B into D? Just substitute all the values. AST we want to calculate 4 number of tensile bars with 22 mm diameter. So AST is calculated as 4 into pi by 4 into 22 square. ASC is 2 into pi by 4 into 16 square. Then we also want to calculate what? PC, and also 100 ASC BD. Okay, PC equal to provide this equation, calculate PC. After calculating, we want to calculate the what? KT, KC and KF. So this question we already learned how to calculate KT. Okay, then KC. This question's KC value is not 1. Why? Because this question is consisting of compression reinforcement. So take the figure number 5. Okay, then the percentage of compression reinforcement, this is page number 39. Okay, then modification factor for compression reinforcement, then we get PC value 0.32. okay, PC value 0.32, so mark 0.32. this is 0.25. okay, 0.32 comes here. 0.32 extend towards the line or the graph given, then extend towards the this y. So first you want to calculate the x-axis PC value, that is 0.32, then extend towards the curve and extend towards y-axis, that is 1.1. so Kc value is 1.1 and Kf is for flanged section. We want to calculate Kf. It is a rectangular section, so Kf equal to 1. Then calculate all the values and check, compare the values. Okay, this question also in the safe condition. Okay, then next question is T-beam. T-beam is a flanged section. So all the steps are similar to the previous one. Only we want to calculate the KF. KF means modification factor. KF means modification factor for this what flanged beam. Okay, flanged beam.